Today we're on 322b. So it says, graph the rational function, locate any asymptotes on the graph. So you need to first figure out, you need to factor the denominator, figure out where the asymptotes and the holes are, and then you need to consider the leading terms to determine where the horizontal asymptotes are, or the slants or quadratics or anything like that, and then graph those. And then there's kind of a silly process we go through to figure out where the graph is. So for number, you guys are doing 29 to 55 odd. So I'm going to work some of the even problems. So number 30. Does it have any holes? No. It does have a vertical asymptote at, so x is not allowed to be equal 2, and that's a vertical asymptote. What about horizontal asymptote? The degree of the bottom is bigger than the degree of the top, so the HA will be at y equals 0. Because when we divide the terms, I get 4 over x, and that can never equal 0. There's no way for 4 over something to equal 0. So to graph this, and we're going to graph them very quickly. So I have a horizontal asymptote at 0, and I'm going to label it as an HA. And then at x equals 2, I have a vertical asymptote. And now I just have to decide, what is the graph going to look like? So it's going to be some combination of, don't draw these yet, of this. It's going to be 2 of those. Okay? So how do we figure out which 2 it's going to be? One of the ones on the right side and one of the ones on the left side. We know that. Okay? And sort of the easiest way to do it is just start plugging in some numbers. So let's plug in, we don't want to plug in x equals 2 because that's a vertical asymptote and we're going to end up getting infinity. So let's plug in 5. 4 over 5 minus 2, 4 over 3, and all we really care about is, when I plug in 4, what sort of number do I get? A positive number or a negative number, right? So it's either going to be something up here or something down there. So by plugging in 4, I have a positive number over 4 minus 2 is positive, and positive over positive is positive, so which of those 2 graphs is it going to be? The top one. So I can get rid of one of those like this. And now on the left side, what do I want to plug in? I want to plug in, I could plug in -2. The easiest one would be 0. So if I plug in 0, I have a positive over a negative, which is a negative number. So it's going to look like that. Okay? Now, once I found one of them, I should have been able to figure out the other one. How did I know that if the right one was on top, the left one had to be on bottom? Yeah, it has something to do with the vertical asymptote. How do I know that this vertical asymptote is going to be approached by 2 different directions? How did I know that if one of them goes up, the other one had to go down? Because x minus 2 only happened once. If it would have been x minus 2 squared, then that asymptote would be approached by the same direction, or they both would have been down. They would both be up, or they would both be down. What if it was x minus 2 to the third? Then there would be an up and a down. Okay, now that gets a little bit more complicated when you throw in multiple vertical asymptotes, so we'll do some of those. Okay, 32. This has a VA at x equals -2, and where is the HA? So if I divide the first two terms, 4x over x gives me 4. So the horizontal asymptote is y equals 4. That's a y. So when I draw this one, I go over to -2 and I have a vertical asymptote. And then I go up to 4 and I have a horizontal asymptote. And this is a little bit harder to graph because we can't just pay attention to signs in this case. If the HA is the x-axis, then when you plug in numbers, you can just test positive and negative. But this time, the HA is up at 4, so we actually need to graph its values. So for the right side of the graph, what's the easiest number to plug in? 0. So I'm going to plug in 0 and 0, and I get 0 over 2 equals 0, which is above or below the HA. Below, so it's going to look like this. Okay. Do I already know what the other one's going to look like? Sure. Where is the other piece going to be? It's got to be on the top left, and I would plug in -3 to check. So if we plug in -3, we would get -12 over -1, which is 12, which is above the HA. So it would be right there. Does that make sense? Okay. All right, 34. So we have a VA at x equals 1. We have an HA where? What are we going to divide to figure out where the HA is? We're going to divide the largest degree on top by the largest degree on bottom, and x over x is 1. So y equals 1 is the HA. Okay. So x equals 1 is our vertical asymptote. Y equals 1 is our horizontal asymptote. What number do we want to plug in on the left side? 0. So I plug in 0, and I get 2 over -1, which is above or below the HA. So 2 over -1 will give us -2, which is below the HA. So 0, -2 is one of the points. So the left side of the graph is going to look like this. And because x minus 1 in the denominator only happens once, I know that the other side of the graph will look like this, which you could figure out by plugging in 2. So if I plug in 2, I get 4 over 1, which is above the HA. Does that make sense? Okay. All right, 34. Okay, let's do 36 together. So first off, we need to factor the top and factor the bottom. 3 times x minus 1, x plus 1. And on bottom, I'm going to have x times x minus 1. The x minus 1's cancel, which create what on the graph? Oh, x minus 3. Oh, I made it too easy. Okay, sorry. X minus 3, so it doesn't cancel. Glad you guys are here, keeping me straight. Okay, so I was trying to say there's a hole, but there are no holes because nothing canceled. So we have vertical asymptotes at x equals 0 and at x equals 3. Everybody gets that, right? Okay, what about HAs? Does this have an HA? Well, this would be 3x squared divided by x squared gives us y equals 3. So if I draw the graph, the y-axis is a VA. And we have another one at 3. And then we have an HA at y equals 3. So we kind of have 3 different sections. We have this piece, and then the center piece, and then the right side piece. And this is a little bit harder to figure out. Let's test the left side by plugging in -1. So I go back to the original equation, and I plug in -1. -1 squared is 1. 1 minus 1 is 0, and 3 times 0 is 0 over. Do I even need to worry about the bottom? Whatever it is, 0 over anything is 0. So on this left side, where is the graph going to be? It's going to be on the bottom. So it looks like this. Okay. Now, let's do the right side, and then we'll deal with the middle. So on the right side, I'm going to plug in 4. So 4 squared is 16. 16 minus 1 is 15, and 3 times 15 is 45 over 16 minus 12, which is 4. And all I care about is that 45 over 4 compares to, it's above y equals 3. I don't care how far above it is, but this number is above the HA, so the graph is going to look like this. So what do you think the middle is going to look like? Well, none of the factors in the denominator happen more than once, which tells us that no asymptotes are approached in the same direction, and we have 2 asymptotes. So the only possibility would be, well, it's got to have something. It's got on 0, it has to be approached on what side? It's got to start at the top and go down, and then the other one has to go like that. So this VA is approached on the bottom on the left side and on the top on the right side, and then the other way around. Now, it is possible to get something to look like this or like this. It just depends on what happens on the other side of the asymptote. How many? So if this VA actually happened twice, then the bottom graph would be correct. So the tricky part is, in the middle, plugging in numbers isn't really very useful unless you plug in something really close to the asymptote. And you might think, well, that's a problem. We crossed the asymptote, but asymptotes really only count on the fringes. They only count for really, really large numbers. So you can cross through an asymptote as many times as you'd like toward the center, but on the edges they approach it. And you can actually have, an asymptote that looked like this. And it crosses it an infinite number of times, but it's getting closer and closer and closer to that line. Now that will only happen in trigonometry, so you won't see it here. Okay, so if you were to plug numbers in the middle, you would want to plug in something like 0.1. Plugging numbers in the center between those 2 asymptotes isn't going to tell you any useful information. So you'd want to plug in 0.1, and you'd want to plug in like 2.9. And then that will tell you where the ends would be. Or you can just use the rule, if a factor happens twice, then the asymptote is approached on two sides. And if it only happens once, then they go in opposite directions. Okay. Look at um, look at number 40. What are the roots of the denominator? Plus or minus 2i. So when does the denominator equal 0? Never. Not in the real world. So this has no vertical asymptotes. Okay? And then when we divide the leading coefficients, we end up with 3x. And 3x is just the slope of the slanted asymptote. And I messed this up the other day, so I apologize. If you want to find the actual equation of the slanted asymptote, you need to use long division and then just throw out the denominator. So I'm going to build a box. X squared, 0x, and 4. And then this first one is going to be 3x to the third. So this would be 3x, 0x squared, 12x. Now 0x and this box, sorry, 0x squared and this box have to add up to 5x squared. So this would be 5x squared. I don't know why I have a negative there. Oh, it wasn't a negative. So this would be plus 5. And this is all going to be remainder. And the remainder does not come into play when you're talking about the slant asymptote. So we can stop here. The slant asymptote is at 3x plus 5. So if I draw the graph, up 3 over 1. Oh, sorry, that should be dotted. That is the slant asymptote. And then what is it going to look like? So if we plug in 0, so 0 plus 0 minus 0 over 0 plus 4, 0 over 4. So it's right there. And then let's plug in, this is kind of a pain, negative 3. Is that actually going to go into it? I don't know. So if we plug in negative 3, that would be 27 times 3 is 81. 15 times, 5 times 9 is 45. Minus 6 over 9 plus 4 is 13. Did I mess something up? Oh, they were negatives. I messed it up. What I would do in this case, if you have a slanted asymptote, I would just put parentheses around this and graph it. But you do need to calculate the slant asymptote so you can draw it on there. But graphing the other ones doesn't always make sense because sometimes the graphs are so close to the axes you can't even see them. So for something like this, I would just plug it in your calculator, graph it, and then draw what you see. Okay. Any questions? All right. Get to work.